Welcome to Orbit Observer. Settle in. Wherever you are right now, whatever kind of day is finally letting go of you, you can set it down. You don't have to hold it anymore. Loosen your shoulders. Let the pillow take the weight of your head. There is nothing to solve tonight, nothing to chase, nothing that needs you to stay awake and worry it over one more time. I'm going to tell you a slow story about a very small thing that does a very large and gentle thing, out past the edge of everything, in the cold quiet around Saturn. And you are welcome to drift off at any point along the way. You won't miss anything. The story keeps moving whether you're following it or not, the way waves keep rolling in, even when no one is on the shore to watch them. So let me begin with the picture I want you to fall asleep inside of. Imagine a wall of ice, not a small one. A wall more than 1 kilometer tall, a sheer face of pale ice standing up against the black, taller than most of the mountains you have ever seen from a car window, taller than the clouds on a summer afternoon. Now imagine that this enormous wall of ice is standing up off a surface so thin, so impossibly, delicately thin that it makes no sense at all. The surface it rises from is only about 10 meters thick. 10 meters, that's roughly the height of a 2-story house. A sheet no deeper than a small building, spread out flat across a distance you could not walk in a lifetime, and rising up out of that gossamer sheet, in a few particular places, are walls of ice more than 1 kilometer high. Just sit with that for a moment. A ring only 10 meters thick, and waves standing 1 kilometer above it. That is not a ripple. That is a mountain of ice lifted off a page. And what lifted it is the strangest part of all, and it's the reason we're here tonight, and the reason I'll keep coming back to this picture again and again as the hours go by. Turning it over slowly, letting it settle deeper each time. What lifted that wall of ice is a moon smaller than a city. Its name is Daphnis. And I want to say that name a few times tonight, softly, because it's a lovely thing to fall asleep on. Daphnis, it's only about 8 kilometers across. 8 kilometers. That's smaller than a lot of the towns you've driven through and forgotten. Smaller than the distance you might jog on a good morning, a little icy world you could very nearly cross on foot in an afternoon if it were somehow solid ground and not a frozen speck adrift in the dark. 8 kilometers wide, and yet this tiny thing is reshaping a ring around Saturn that is tens of thousands of kilometers around. A structure so vast that if you tried to follow its curve, you would travel something on the order of 40,000 kilometers to come all the way back to where you started. 40,000 kilometers of ice and shadow and slow, patient motion being sculpted at its edges by a moon you could lose inside a single one of Earth's cities. That's the whole mystery I want to carry you into tonight. How does something that small make waves in something that big? How can a body no wider than a town lift walls of ice off a ring the size of a world? It sounds like it shouldn't be possible. It sounds like the numbers were written down wrong. And yet it is real. All of it is real. It was photographed by a spacecraft that circled Saturn for 13 years. And by the end of these hours together, I'll have walked you gently all the way through it. Every piece of it, slowly, more than once, so that the strangeness turns from something startling into something soothing. The way an unfamiliar room becomes familiar once you've lain in it long enough in the dark. But for now, we don't need the whole answer. For now, I just want you to hold the picture. The small moon. The enormous ring. The wall of ice standing up off a sheet as thin as a house. Let me tell you where all of this is happening. Because the place matters, and the place is beautiful. You know Saturn. Even if you've never looked at it through a telescope, you know the shape of it, the round golden ball with the rings drawn around its middle, tilted just so, like a hat set at a jaunty angle. Almost every child draws Saturn the same way. It is the one planet that looks, from a distance, exactly like the toy version of itself. And those rings, which look from far away like solid painted hoops, like flat bands of light wrapped around the planet, are not solid at all. They never were. They are made of countless separate pieces, mostly water ice, everything from tiny grains no bigger than dust and snowflakes, all the way up to chunks and boulders several meters across, each one going around Saturn on its own quiet path. All of them together, catching the sunlight and throwing it back at us so brightly that we can see the rings from hundreds of millions of kilometers away. That brightness is ice. The rings shine because they are, in a sense, a vast field of tumbling snow and hail and slabs of frozen water, all orbiting in a plane so flat and so wide it defies the imagination. Now, the rings aren't a single smooth thing. They have divisions, bright regions and darker regions, and different bands that astronomers have given letters to, and the one that concerns us tonight is called the A-ring. The A-ring is the outermost of the big, bright main rings. Think of it as the last broad, luminous band before the rings finally thin out and fade into the dark at their outer edge. And it's out here, near the outer part of the A-ring, that our little moon lives. Because cut into that outer part of the A-ring, there is a gap, a dark lane, a clearing swept through the shining ice, where the ice mostly isn't. It's called the Keeler Gap, and I'll tell you later why it carries that name, because there's a good human story in it. For now, just picture the gap itself. A dark ribbon of empty space, running all the way around the planet, threaded through the bright ice like a groove worn into a record, or like a firebreak cut clean through a forest, or like a path mowed through a wide field of pale grass. On either side of that path, the ring goes on, shining, dense, full of ice. But within the path, there is mostly darkness, a clear lane. The Keeler Gap is only about 42 kilometers wide. In the scale of Saturn's rings, which stretch across a span you could lay many Earths across. 42 kilometers is nothing, it's a thin dark thread, a hairline of shadow drawn through the brilliance. And it sits far out from the planet, roughly 6,500 kilometers from the center of Saturn, tucked in only about 250 kilometers inside the very outer edge of the A-ring. So this dark little lane runs near the outer rim of the last great bright ring, all the way around the planet, a circle so enormous that the lane itself, though it looks like a fine line, is really a loop tens of thousands of kilometers long. And in that lane, all alone, drifts Daphnis. That's the setting. That's the stage. A dark, narrow path swept clean through a field of shining ice out near the edge of Saturn's brightest ring, and one small icy moon travelling along it in the quiet. Hold that, too, alongside the wall of ice. A dark lane in a bright field, and a little moon riding down the middle of it, over and over, forever. Now I want to tell you about the rhythm, because this is where the story turns from a picture into a motion, and it's the motion I most want to carry you to sleep on. Daphnis is not sitting still in that gap. It's moving. It's orbiting Saturn, the way our own moon orbits the Earth, the way all these bodies circle their planets, going round and round on a path that never ends. But where our moon takes about a month to go around us once, Daphnis, being so close into Saturn and travelling so fast, goes all the way around in a little over 14 hours. About 14 1/3 hours, to be more exact, roughly 14 hours and 20 minutes, which comes out to a bit less than 6/10 of a single Earth day. So in the time it takes you to sleep one night and get up and go through a whole long day and come back to bed again, Daphnis has already circled Saturn nearly twice. Around and around and around, a full lap of that vast bright ring completed before you've finished a single day of your life. Think about how fast that is, and yet how calm it looks from far away. From a great distance, from where a spacecraft might watch it, the moon seems barely to move. It just eases along its dark lane, gliding, silent, patient. But it's travelling at a tremendous clip, fast enough to lap a ring 40,000 kilometers around in the span of an afternoon and an evening. Fast and slow at the same time, the way the minute hand of a clock is technically racing and yet seems, to your eye, to be perfectly still. That's the quality of it. Enormous speed that reads, from the outside, as pure serenity. And here's the thing that speed does. Here's the motion I want you to feel. As Daphnis glides down its dark lane, it passes close to the walls of ice on either side. The inner edge of the gap and the outer edge of the gap, the two bright banks of the dark path, and as it passes each stretch of edge, its gravity reaches out and gives the ice there the smallest, gentlest tug. A pull, a nudge. Nothing violent, nothing sudden, just the quiet, invisible hand of gravity brushing the ice as the moon slides by, and that nudge sets the edge of the ring rippling. The picture I keep coming back to, the one that fits it best, is a boat on still water. You've seen this. Maybe you've been in the boat, or maybe you've just watched from a dock or a bridge as one went by. A boat moves across a smooth, quiet lake, and behind it and beside it, it leaves a wake, those long spreading ripples that trail out from the hull in a widening pattern. Rolling gently across the surface, lifting and falling, moving outward from the path the boat cut. The boat doesn't have to try. It doesn't have to do anything but move. The wake is simply what the water does in answer to something passing through it. That is what Daphnis does to the ice. It is the boat, and the ring is the water. And the wake is a train of ripples running along the edges of the gap, trailing behind the little moon as it glides through. A slow wake of ice, ripples spreading along the bright banks of the dark lane, rising and falling, in answer to the moon's quiet passage. And because Daphnis goes all the way around every 14 hours or so, this wake is being made again and again and again, an endless, unhurried carving of the same ripples along the same edges, a rhythm with no beginning that anyone can point to, and no end. Nudge and ripple. Nudge and ripple. The boat glides through, and the water answers, and then the boat comes around and glides through again. There is something in that rhythm that I find deeply restful, and I hope you do too. It asks nothing of you. It just repeats. A small thing moving through a great stillness, leaving waves behind it. Forever the waves rise, and the waves ease, and the moon comes round again. If your mind has been noisy today, if it's been building and building, one thought stacking on the next like static that won't quite settle, that low hum of everything you didn't finish, and everything tomorrow might ask, then let this be the thing you rest it against. Not silence, because silence can be hard when the mind is loud, but a slow, gentle, repeating motion, a wake on dark water, a wall of ice rising and easing, a small moon gliding round and round and round. Before I carry you any deeper, let me do one small thing, and then I'll leave you undisturbed for a long while. I'd love to know where you're listening from tonight. Wherever in the world you are, whatever the hour is where you are, whatever the weather is doing outside your window, whatever room you've made dark and comfortable to rest in, If you feel like it, and only if it's easy, you can leave a note in the comments and tell me the place. I read them. It's a quiet pleasure of mine. On the nights I can't sleep either, to see all the different corners of the world where people are lying in the dark, letting the same slow story carry them off. It makes this vast, cold subject feel a little warmer, a little more shared. And if you're new here, and you'd like more nights like this one, more slow journeys out to quiet places, told at exactly this unhurried pace, you're welcome to subscribe so the next one finds its way to you. That's all. You never have to do a thing for this story to keep going. Consider it done and let your hands go still again. Now, back to the ice. I told you the picture, and I told you the rhythm, and now I want to open up the mystery a little wider, because the more you look at it, the stranger and more beautiful it gets, and the strangeness is the kind you can rest in, rather than the kind that keeps you up. There are a few particular puzzles hidden inside this simple picture of a small moon making waves, and I want to name them now, gently, and just leave them sitting in the dark for you, the way you might leave a few smooth stones on a windowsill to look at later. I'm not going to solve them yet. I'm going to set them down, one by one, and we'll come back to each of them slowly over the hours ahead, turning them over, finding the answers together. For now, they're just 3 quiet questions to hold. Here's the first one, and it's the one I opened with, because it's the one that never stops being astonishing. How does a wave stand a kilometer tall on a sheet only 10 meters thick? Really sit in the impossibility of that. The rings are thin, not thin like a sheet of paper is thin compared to a book, thin like a single page laid across a football field, thin beyond anything in your everyday experience. In many places, Saturn's main rings are only about 10 meters thick, top to bottom, even though they run for hundreds of thousands of kilometers across. If you could somehow shrink the rings down and hold them, they'd be more delicate than the thinnest foil, a shining film stretched impossibly wide and flat. And out of that film, in the places where Daphnis has passed, ice rises up not 10 meters, not 100, but something like 1,000 meters and more, up to a kilometer and a half in places. Walls of ice 100 times taller than the sheet they stand on, or more. It is as though a puddle only a few centimeters deep suddenly threw up a wave taller than your house. It doesn't seem like the material is even there to do it. Where does a 10-meter sheet find a kilometer of height? That's the first stone on the windowsill. How the wave can be so tall on something so thin. Leave it there. We'll come back to it, and the answer, when it comes, involves a single rare day when the sunlight fell across Saturn's rings from exactly the right angle and made the invisible visible, but that's a long way off yet, and you may well be asleep before we reach it, which is perfectly all right. Here's the second question. Why don't the two sides match? Remember, the Keeler Gap has 2 banks, an inner edge closer to Saturn and an outer edge farther from the planet. And Daphnis, gliding down the middle, tugs on both of them. You might reasonably expect the ripples on the 2 edges to mirror each other, like the wake spreading out evenly on both sides of a boat, a neat, matched, symmetrical pattern. But they don't match. The waves on the inner edge and the waves on the outer edge are out of step with each other. Offset, as if 2 people were shaking out 2 bedsheets side by side, but not quite in time, so the crests and troughs don't line up. One edge is rippling here, while the other edge is rippling a little farther along. It's a subtle thing, and it took careful eyes to see it, but it's real, and it's a clue. A clue about the way things move at different speeds when they're at different distances from a planet. That's the second stone. Why the two edges wave out of step? Set it down beside the first. The answer, when we get to it, is one of the quietest and most elegant ideas in all of this, and it comes from something as simple as the fact that things closer in go faster. And here's the third, and it's the gentlest of them, more of a curiosity than a puzzle, but I love it, and it's a good one to fall asleep wondering about. Why is this moon named after a shepherd? Because it is. Daphnis, the name, comes from an old Greek story. Daphnis was a shepherd, a pastoral figure tied in the myths to the god Hermes, a keeper of flocks, a boy with a flute among the sheep on a hillside, and someone, when they had to name this tiny icy moon, chose the name of a shepherd on purpose, because of what this moon does. Because in a way I'll explain to you slowly, Daphnis tends its gap the way a shepherd tends a flock, keeping the ice from wandering where it shouldn't, nudging strays back into place, holding the dark lane open and clear by its constant, patient presence. Whether you find that a stretch of poetry or a perfect fit, I'll let you decide as we go. For now, just hold the image, a shepherd, alone, walking a dark path through a field of shining ice, keeping the way open, keeping the flock in line, hour after hour after hour, never resting, never hurrying, going round the whole enormous field once every 14 hours, and beginning again. That's the third stone. Why a moon is named for a shepherd. 3 quiet questions then laid out on the windowsill in the dark. How the wave stands so tall on something so thin. Why the two edges ripple out of step. Why the moon carries a shepherd's name. You don't have to remember them. I'll bring each one back myself in its own time and answer it slowly and completely so that nothing is left dangling by the end. Tonight is not a night for loose ends. Tonight everything gets tucked in. Let me just widen the frame once more before I let the rhythm take over for a while, because I want you to feel the full sweep of the scale, since the scale is really the whole wonder of it. Picture the sizes again, laid side by side, spoken slowly. The moon about 8 kilometers across. A small town's worth of ice. The gap it keeps, about 42 kilometers wide. A lane you could drive the length of in half an hour if there were any ground to drive on. The ring it lives in, the outer A-ring, out around 136,000 kilometers from Saturn's center, part of a system so wide that our whole planet could be laid across it several times over. The circle it travels, 40,000 kilometers around, a loop so long that the moon, moving fast enough to lap it in an afternoon and evening, still seems from far away to barely creep along. And the waves it raises, up to 1.5 kilometers tall, standing off a sheet only 10 meters thick. Now hold all of those numbers together in your mind at once, if you can, and feel the disproportion of it, the almost tender absurdity of it. The smallest thing in the picture is doing the shaping. Not the ring, which is vast, not the planet, which is enormous beyond imagining. The little moon, the 8-kilometer speck, the one you could almost overlook entirely, is the sculptor. It moves, and 40,000 kilometers of ice arranges itself around that movement, opening a clear lane where the moon passes, rippling at the edges where the moon tugs, lifting into walls where the geometry is just right. A town-sized body, patiently keeping order across a ribbon the size of a world. There's a lesson in that if you want one, though you don't need a lesson tonight and I won't press it on you. But it's a comforting thought to drift on, so I'll just place it here gently. Small things shape large ones. Not by force, Daphnis has almost no force to speak of, being a loose little pile of ice with the faintest whisper of gravity. It shapes the ring by being steady, by being present again and again, on the same path, at the same slow rhythm, never dramatic, never sudden, just there, tugging so lightly that a single pass would hardly matter, and yet passing so faithfully, so endlessly. Orbit after orbit after orbit, that over time the whole ring takes its shape from that gentle, repeated touch. The gap stays open not because the moon shoves the ice aside all at once, but because it comes by, and comes by, and comes by, and the ice, answering each small nudge, settles into the pattern the moon asks for. Steadiness, not force. Repetition, not drama. The wave is made by patience. And that, really, is the shape of the whole night I want to give you. Steadiness, repetition, the same gentle motion, returning and returning, until it has quietly reshaped the noise in your head into something calm, the way the little moon reshapes the ring. You don't have to force sleep tonight. You don't have to shove the day's thoughts aside all at once. You only have to let the rhythm come by. And come by, and come by, the moon gliding down its dark lane, the wake spreading along the bright banks, the wall of ice rising and easing, the 14-hour loop closing and beginning again, until, without your quite noticing the moment it happens, the pattern has settled you. So let's stay with it a while longer, that motion, and let me picture it for you once more, slower this time, with nothing new added, just the same wake drawn again in the dark, the way you'd smooth the same blanket twice, because the smoothing itself is the comfort. Out past everything, in the cold and the quiet, where the sun is only a very bright star, and Saturn hangs enormous and golden and ringed. There is a dark lane cut through a field of shining ice. The ice is water, countless pieces of it, from grains like snow to boulders like boats, all going around the planet together, all catching the far light and giving it back, so that the whole vast ring glows. And through the dark lane in the middle of that glow, a small moon is gliding. Daphnis, 8 kilometers of loosely packed ice, riding down the clear path it keeps clear simply by riding down it. As it moves, its faint gravity brushes the bright banks on either side, and the ice there answers, rising into a slow ripple, a crest and a trough and a crest again, a wake trailing out behind the little moon along both edges of the lane. And where the geometry is just right, that ripple doesn't only run along the surface, it lifts. It stands up out of the impossibly thin sheet, a wall of pale ice a kilometer and more into the black, a mountain raised off a page, holding there for a while in the silence, and then easing back down as the moon moves on. And the moon does move on, always gliding down the lane, round the whole enormous circle, 40,000 kilometers, a little over 14 hours, and then it comes round to the same stretch of edge again, and brushes it again, and the ice ripples and rises and eases once more. Nudge and ripple, rise and ease. The boat glides through, and the water answers, and the boat comes round again. There is no sound out there. That's the last thing I want to leave you with before I let the story run quiet for a while. In all of that motion, the moon racing round the planet, the waves standing a kilometer tall and settling back, the ribbon of ice 40,000 kilometers long endlessly reshaping itself at the touch of a town-sized speck, there is not one whisper of sound. Space carries no sound. It all happens in perfect silence. The walls of ice rising and falling like a slow tide, with no shore and no roar, only the light. A silent wake on a silent sea, made and made again, out where no one is watching, going on right now. Tonight, as you lie here in the dark, Daphnis gliding down its lane at this very moment, tugging up its quiet waves, keeping its shepherd's watch over the flock of ice, whether anyone knows it or not. And we do know it. That's the wonderful thing, and it's where this story is going to take us, slowly, in the hours ahead. We know all of this because we sent something out there to look, a spacecraft that circled Saturn for 13 years and got close enough on one particular pass to photograph the little moon in its lane and catch, in a single frame, a faint thread of ice being drawn up out of the ring toward it, like a strand of wool caught on the shepherd's hand. But that's a picture for later. That's a stone I'm not quite ready to set on the windowsill yet. For now, there is only the rhythm, and you resting in it. The dark lane, the bright banks, the small moon gliding and gliding and gliding, the wall of ice rising off the thinnest sheet and standing a moment in the silence and easing back down, rising and easing, coming round and round and round. Let it carry you. You don't have to hold on. The waves will keep rising whether you follow them or not, and I'll keep telling them softly, all through the dark out here where the little shepherd walks its lane, and the ice answers its gentle hand, 40,000 kilometers of quiet, one small moon, and one slow wake spreading forever along the edges of the gap. So let us go there slowly. Let us take our time, the way you take time with something you want to understand fully and carry with you, not as a fact you could recite if asked, but as a place you have genuinely visited, somewhere in the mind, somewhere that stays with you in the small hours when the world outside has gone quiet and the distance between you and the dark of space feels, somehow, much smaller than it does in the daylight. There is no hurry. The waves will still be rising when we arrive. Daphnis will still be making its long, patient loop through the gap, and we will be there for it. We will be standing, in imagination at least, close enough to see the bright banks curving away on either side, and the small dark body moving through its lane with the slow certainty of something that has done this millions upon millions of times, and will keep doing it long after tonight. The place we are going is called the Keeler Gap. Say that name and let it sit for a moment, because it is one of those names in planetary science that sounds like a door left slightly open. A gap, as the word tells you plainly, a space between things, an absence in the middle of something that otherwise continues. And yet, the Keeler Gap is not nothing. A gap in Saturn's rings is a remarkable and specific thing. It is a lane that has been kept clear, swept clean by the passage of something moving through it, the way a slow broom drawn across a dusty floor opens a corridor of bare wood on either side. To have a gap at all, you need something doing the sweeping. And in this gap, that something is Daphnis. The Keeler Gap is roughly 42 kilometers wide. Hold that number in your mind the way you might hold a stone, turning it over, feeling its weight. 42 kilometers. That is not a trivial distance. In a different context, 42 kilometers is a considerable drive, the kind of journey that takes half an hour on an open highway. The kind of span you might watch roll by through a car window on a winter afternoon, watching fields and tree lines and the occasional distant building pass. 42 kilometers of cleared open lane, sitting in the outermost section of Saturn's main ring system, swept and maintained by an 8-kilometer moon. And yet, in the context of Saturn's rings as a whole, 42 kilometers is narrow. It is a a seam in a vast bright fabric. The rings themselves extend for hundreds of thousands of kilometers in total, and within that immensity the Keeler Gap is a fine, almost delicate dark thread, a hairline crack in the brightness, something you could easily miss if you were not looking closely. You have to look closely to find Daphnis. You have to look closely to find the gap. That is part of the story. The gap sits inside the A ring, which is the outermost of Saturn's main bright rings. When you see Saturn in a photograph, the planet with the rings, the image so familiar it has become almost an icon, a symbol for the idea of a ringed world. The bright structure curving around it on either side is made up of several distinct bands. The innermost of the main rings, the D ring, is faint and tenuous. Then come the C and B rings, the B ring being the widest and brightest of them all. Then there is the Cassini division, a dark gap large enough to be visible from Earth, wide enough that for a long time astronomers thought it was empty space. And then, beyond the Cassini division, the A ring, the outermost of the four main bright rings, curving away from the planet into the darkness before the ring system thins out and ends. The A ring is not small. It stretches from roughly 122,000 kilometers from Saturn's center out to about 137,000 kilometers, spanning something like 15,000 kilometers of width in its own right, a bright arc of ice and rock circling a planet nearly 10 times the size of Earth. Daphnis sits inside that ring at roughly 136,500 kilometers from Saturn's center, which puts it about 250 kilometers inside the A ring's outer edge. 250 kilometers from the edge of a ring that is 15,000 kilometers wide. Barely inside the door, so to speak, nearly at the boundary. And in that near outer position, the little moon keeps its lane, and the lane keeps its shape, and the ice on either side piles softly into waves and eases back, over and over, in the long silence. Now, the ring itself. The material that Daphnis is actually moving through, and disturbing, and lifting into those quiet vertical walls that rise and fall like a breath. Saturn's rings are made almost entirely of water ice, not rock, not metal, not the kind of material you find in asteroid belts or rocky moons, water ice. The same basic substance that glazes a puddle on a cold night, the same chemistry that builds a snowflake or a glacier, the same molecular arrangement that makes up the ice in a glass of water left too long on a countertop in winter. Out there, at Saturn's distance from the Sun, 9.5 times farther than the Earth, far out in the cold outer reaches of the solar system, water freezes. It freezes hard and clean, and it stays frozen, and when you collect enough of it, over billions of years, in the orbits just outside a gas giant's gravitational heart, you get Saturn's rings. You get that luminous, improbable structure. A disk of water ice circling a planet, shining in the far-off sunlight, bright enough to see from the ground on Earth with a decent pair of binoculars, if the angle is right. The particles themselves vary. At the smallest end, they are tiny, fine icy grains, specks of frost drifting in their orbits like the finest snow. At the larger end, they grow to several meters across. Irregular chunks of ice the size of small boulders, tumbling slowly as they circle, reflecting the faint but steady light. Most of the particles are somewhere in between, centimeter-sized, maybe up to tens of centimeters, the scale of snowballs, of gravel, of river stones made of ice. The full range spans from grains you could hold in your palm, with no trouble at all, to boulders that would fill a room. And all of them, every tiny grain and every meter-wide chunk, are orbiting Saturn independently, each in its own path, each following the curve that gravity demands of it at its particular distance from the planet. Billions upon billions of individual pieces of ice, moving together in a disk so thin that if you shrank the rings down to the size of a piece of paper held flat in your hand, the thickness of the paper would actually be a reasonable approximation. In some regions of the rings, a generous one. Some sections of the main rings are no more than 10 meters deep from top to bottom. 10 meters, 30 feet. The height of a typical 3-story building. A disk of ice stretching hundreds of thousands of kilometers across and only as deep as a modest house is tall. The proportions are almost impossible to hold in the mind all at once, and yet they are true. This is what Daphnis is working with. A 10-meter sheet of loose, tumbling, drifting water ice, stretching away on either side of the gap for thousands of kilometers, and the moon's gravity, weak as it is for such a small body, is enough, just enough, to reach into the edges of that sheet and lift some of it upward, to disturb the flat plane, to push and pull the particles at the boundary of the Keeler Gap out of the horizontal and into the vertical, raising them up into structures that climb, in places, a kilometer or more above the ring plane. A kilometer, 100 times the thickness of the sheet itself. Standing a wall of ice a kilometer tall off a surface 10 meters deep is, proportionally, something like raising a column of water 300 meters high off a layer of water 3 millimeters deep. It is not what the sheet expects. It is not what the physics of the flat plane, undisturbed, would produce. It takes something to do that. It takes a shepherd. But before we follow the shepherd into the mechanics of how it does its work, before we watch the waves actually rise, which we will do, slowly in the hours ahead, it is worth stopping here, in the gap, in the bright ice, and thinking about how we know that any of this is so. How we came to understand that the rings are countless separate pieces of ice at all, rather than a solid structure, or a liquid, or a fog. Because the understanding of what Saturn's rings actually are did not come quickly or easily, and the story of how it arrived is a small, quiet story worth telling in a room where the night has settled and there is no particular hurry to get anywhere. The name of the gap tells part of it. Keeler, James Edward Keeler. Keeler was an American astronomer who lived in the 19th century, and in 1895 he did something that sounds, described simply, almost mundane. He pointed a spectrograph at Saturn's rings. A spectrograph is an instrument that splits light into its component wavelengths, the way a prism spreads white light into a rainbow. And when Keeler looked at the spectrum of the light coming from Saturn's rings, he was looking not just at the light itself, but at a very subtle shift in the wavelength of that light, a shift caused by the motion of the source, the same phenomenon that makes a passing siren rise and fall in pitch as it approaches and then recedes. This is called the Doppler shift, and it is a way of measuring motion precisely by reading the change that motion imprints on a wave. What Keeler found in 1895, looking at the rings through his spectrograph, was that the inner edge of the rings was moving faster than the outer edge. The inner particles were orbiting Saturn more quickly. The outer particles were moving more slowly. And this pattern, faster inside, slower outside, is exactly what you would expect if the rings were made of countless separate particles, each orbiting the planet independently under gravity's pull, the way planets orbit the sun, the inner ones quick and the outer ones slow. It is not what you would find if the rings were a solid disk. Because a solid disk rotates with its inner and outer edges moving at different speeds only in a very different way, The outside of a spinning plate moves faster than the center, not slower. Rings, if they were a solid disk, would spin like a plate. They did not. They orbited like a collection of independent objects, and Keeler's measurements proved it. This was not a small thing. The question of whether Saturn's rings were solid, liquid, or made of separate particles had been debated for decades. The mathematical proof that the rings could not be solid had come 36 years earlier, from a Scottish physicist named James Clerk Maxwell, a man whose work in electromagnetism and thermodynamics stands among the great intellectual achievements of the 19th century. In 1857, Maxwell had shown, through a careful and rigorous mathematical argument, that a solid ring around Saturn would be gravitationally unstable, that it would break apart. The rings, he reasoned, had to be made of countless small separate bodies, each in its own orbit. This was a theoretical conclusion, an argument from mathematics, and it was almost certainly correct. But it had not been directly observed. Keeler's 1895 spectrograph work was the direct observational confirmation of what Maxwell had shown must logically be the case. The rings are not a solid structure, they are a collection, vast, brilliant, improbably thin, of individual pieces of ice, each one on its own path, each one answering to gravity on its own terms. And from that established fact, everything else about the rings, everything about how Daphnis does what it does, everything about the waves and the gap and the shepherd's roll, follows as clearly as one stone laid after another in a wall. Because if the particles are independent, then they can be disturbed independently. A force applied to one does not necessarily transmit to the next, the way a force applied to one end of a solid board transmits directly to the other. Each particle can be nudged, tugged, lifted out of its path and into a new one, while the particles beside it follow slightly different paths at slightly different speeds. And this is the foundation of everything Daphnis does. The gap, the waves, the offset ripples, the vertical structures rising off the ring plane, all of it rests on the fact that James Edward Keeler pointed a spectrograph at Saturn in 1895 and read the Doppler shift in the ring's reflected light, and found what Maxwell's mathematics had predicted. Separate particles, each one free to move in its own way. Each one available to a small passing moon, circling close, reaching out with the patient, tireless hand of gravity. The gap is named after Keeler. That is the right sort of tribute for a man whose work made the gap's existence meaningful, not just as an aesthetic feature of the ring system, not just as a dark space in the brightness, but as evidence of a physical process. A gap kept open by an ongoing gravitational conversation between a small moon and the countless independent ice particles that surround it. Keeler's observation made it possible to understand why the gap is there at all. Daphnis is not alone in this kind of work. There is one other moon in Saturn's ring system that occupies a similar position, living inside a gap, keeping its lane clear, shaping the edges of the channel it travels. That moon is Pan, and it is the elder of the two gap moons, larger, discovered years earlier, working in a different part of the ring system. Pan lives in the Encke Gap, which is farther inward than the Keeler Gap, deeper into the A-ring, not so close to the outer edge, and considerably wider. The Encke Gap is roughly 325 kilometers across, compared to the Keeler Gap's 42 kilometers. Pan is wider too, roughly 28 kilometers in diameter, compared to Daphnis's 8, though Pan has the same characteristic shape, a broad equatorial ridge of ring material swept up over time, giving it that distinctive flattened appearance. Like a disc with a raised belt around its middle, or a ravioli pinched at the edges, or a spacecraft from a mid-century illustration, a flying saucer made of ancient ice. Atlas, another small inner moon just outside the A ring's edge, has a similar shape for similar reasons. The ridge is a badge of membership in this small guild of ring sculptors, a sign that the moon has lived long enough, in close enough proximity to a supply of ring material to accumulate a coating of it around its widest point. Pan was found in 1990, 15 years before Daphnis, and it was found in a particular way that is itself a small wonder of astronomical detective work. Mark Showalter, a planetary scientist, went back through old images taken by Voyager, the Voyager 2 spacecraft, which had flown past Saturn in 1981, and found Pan hiding in those images in the Keeler Gap in data that had sat archived for years. The moon was there all along in the pictures. It simply had not been noticed. It was only when someone looked carefully enough, knowing what to look for, that Pan revealed itself in the existing record. Daphnis, by contrast, was found not in old archives but in new data, new images, taken by a spacecraft specifically sent to Saturn for an extended look. The Cassini spacecraft, which arrived at Saturn in July of 2004, began returning ring images almost immediately upon entering orbit, and within a year its cameras had caught Daphnis in the Keeler Gap. Found fresh, in real time, by a mission designed for exactly this kind of discovery. The two gap moons have different origin stories then, Pan recovered from the past, Daphnis found in the present, but they share the same fundamental role, the same patient labour of keeping a lane swept clean. The comparison between them is useful because it throws Daphnis's smallness into clearer relief. Pan, the elder, the one discovered first, is roughly 28 kilometers across, still not large by any planetary measure, still a body that would fit comfortably inside a mid-sized city, but more than 3 times the width of Daphnis. And Pan's gap is nearly 8 times wider than the Keeler Gap. The relationship between a gap and the moon that keeps it open is not perfectly proportional. The physics of gap clearing involves more than just the moon's diameter, but there is a sense in which the Keeler Gap's relative narrowness matches the modesty of its keeper. 42 kilometers, swept by 8. A slender lane for a small moon. What both moons share, however, what makes them something more than mere gap fillers, is the edge sculpting. Both Pan and Daphnis do not simply sit in their gaps and push particles away. They actively shape the banks. The ice on either side of each moon's lane is not a smooth, featureless wall. It is a rippled, waving, continuously disturbed surface. The passage of the moon through its gap does not just clear the center, it reaches out sideways into the ring material on both edges, and tugs and stirs and draws the ice into patterns that trail behind the moon the way a ship's wake trails behind the ship. But the waves that Daphnis makes are, in at least one crucial respect, different. They are not simply horizontal ripples in the plane of the ring. They have a third dimension. They go up. And that, the going up, the vertical component, the walls of ice climbing off the flat ring plane to stand briefly in the silence before easing back down, is what makes Daphnis's story a different kind of story from Pan's. Not just a gap moon. Not just a shepherd keeping its lane, something that reached into the thin, flat sheet of Saturn's outer A ring and built, with nothing but gravity and time and the slight tilt of its own orbit, structures that rose a kilometer above the plane and cast shadows that scientists had not seen before and were not, initially, sure how to interpret. That is where this narration is heading. That is the shape of the understanding we are slowly building together, here in the dark, with no particular hurry and no place more important to be. The setting is established now, the Keeler Gap, 42 kilometers wide, sitting near the outer edge of the A-ring, at roughly 136,500 kilometers from Saturn's center. Embedded in a sheet of water ice 10 meters deep and hundreds of thousands of kilometers wide, its name a tribute to the American astronomer who proved in 1895 what a Scottish physicist had calculated in 1857, that the rings are not a solid thing, not a disk, not a plate, but a population of countless separate particles, each one free to be moved. Each one available to a passing moon's quiet gravitational hand. And in that gap, circling once every 14 hours or so, an 8-kilometer moon keeps its watch. Smaller than Pan, smaller than Atlas, smaller than almost any named moon in the solar system you might care to reach for, but doing something that the larger moons of Saturn do not do. Something that makes the Keeler Gap's bright scalloped edges unlike the edges anywhere else in the rings, pulling the ice not just sideways but up, lifting the flat plane into a third dimension that the ring, left to itself, would never explore. There is a quality to this that I find genuinely difficult to leave behind quickly. The flatness of Saturn's rings, that extraordinary thinness, 10 meters in a structure that stretches for hundreds of thousands of kilometers, is itself one of the most striking proportional facts in the solar system. To have a disk so enormous and yet so impossibly thin is a consequence of the physics of orbiting particles colliding over immense stretches of time, gradually redistributing energy, gradually settling into a plane. Collisions between ring particles, gentle, slow collisions, not violent impacts, bleed off the vertical component of any particle's motion over time. They flatten the disk. Over billions of years, countless gentle collisions have pressed the ring material into a sheet that is, in proportion, far thinner than a piece of paper. If you made a scale model of Saturn's rings from a sheet of ordinary paper, the paper would need to be cut down to something like 1,000th of its original thickness to correctly represent the ring's proportions. Thinner than tissue, thinner than a soap bubble's wall. A sheet of ice stretched across the dark, flat and still and bright as a frozen lake seen from directly above. And then Daphnis comes through once every 14 hours and lifts part of it. Not by violence. Not by collision. Gravity does not work by contact. It does not need to touch the ice to move it. The moon passes, and the ice at the edge of the gap feels the pull, and it responds, not all at once, not in a sudden lurch, but gradually, smoothly, the way water in a glass responds when you tilt the glass slowly, the surface shifting and climbing one side while easing down the other. The ice at the gap's edge rises. It does not rise quickly. This is not an explosion or a geyser. This is slow, calm, inevitable motion in response to a gentle and continuous gravitational call. The wave builds gradually as the moon approaches, reaches something near its maximum height as the moon passes closest, and then subsides, not immediately, not all at once, but over the following orbital period, slowly easing back toward the ring plane as the moon moves on and its pull eases, rise, and ease, and rise again. Every 14 hours. Every time the little moon comes around the bend of its orbit and passes through this stretch of the gap, the ice at the edges responds to it, has been responding to it, presumably for as long as Daphnis has occupied this lane. Will keep responding to it for as long as the moon remains here and the gap remains open. a slow, rhythmic, endlessly repeated exchange between a small icy body and the bright flat ocean it travels through, the most patient kind of conversation. The kind that needs no words and no hurry and no conclusion, only the same gentle question asked and answered on every pass, over and over in the dark. The question the moon asks with its gravity is simple. It is always the same. It is, come with me. Just a little. Just enough to rise. And the ice at the edge of the Keeler Gap answers, as it has always answered, as it will always answer, with the one response it knows, rising, slowly, quietly, in the immense and star-filled silence of the outer solar system, where no sound travels and no wind blows, and the only motion is the motion of things following the paths that gravity has laid out for them across billions of years of patient work. The ice at the edge of the Keeler Gap answers Daphnis's call by rising, and in the rising, it becomes something that the flat ring plane by itself could never be. A vertical structure, a wall of ice, a wave caught mid-crest in the moment before the moon moves on and the pull eases and the ice begins its slow descent back to the plane. A wave made of ice. On Saturn, going on right now, as you lie here in the quiet, and the dark grows a little softer at the edges, and the thoughts that were pressing begin, perhaps, to feel a little more distant, a little less insistent, the way thoughts do when you let them be for a while and stop asking them to mean something urgent. The gap is 42 kilometers wide. The moon is 8 kilometers across. The ring is 10 meters deep, and the waves rise a kilometer. Those numbers are where we are going next, into the mechanism, into the physics, into the reason the two edges of the gap ripple out of step with each other, into the slight tilt of the orbit that gives the waves their height. We will go there slowly, the way you go somewhere you want to fully see, not rushing to arrive, but letting the journey be the thing, the path through the explanation itself, becoming the experience of understanding it, so that by the time we reach the pictures, the photographs that Cassini took in 2009 and again in 2017, the images that showed the world what this small moon was doing in its lane, the numbers will be part of you, and the pictures will arrive with the satisfaction of something confirmed rather than something strange. But that is ahead. For now, the setting is enough. The gap named for a man who read the light of Saturn's rings in 1895 and found the motion of countless independent pieces of ice encoded in the shift of a spectrum. The ring of water ice, thick as a 3-story building, broad as the distance from here to the moon, and then some, curving around a gas giant 9.5 times farther from the sun than the Earth is. And inside that bright, improbably thin disk, in a narrow lane 42 kilometers wide near the outer edge, a moon the size of a small city making its loop once every 14 hours and lifting the ice at the edges of its gap into silent, slow, enormous vertical waves. All of it turning and turning out there in the dark. All of it going on at this moment while you breathe and rest and let the voice come to you from wherever voices come from in the quiet hours. Daphnis making its circuit, the ice lifting and easing, the gap holding its shape. The long history of observation and mathematics and careful looking that made it possible for us to know any of this, reaching back through a spacecraft named Cassini and a gap named for Keeler and a proof written by Maxwell in 1857. All the way back to the first moment someone looked up at Saturn from the ground and noticed that there was something bright and strange around it and wanted very much to understand what it was. That wanting is part of this too. The wanting to understand. the patience that understanding requires, the willingness to go slowly, to look again, to wait for the light to be right, to point an instrument at something far away and read what it is telling you in the language of waves. Not so different, perhaps, from lying in the dark and letting a quiet voice bring something distant and strange a little closer. Letting the numbers settle into the mind, not as facts to be remembered and tested, but as the real proportions of a real place, out there in the solar system, that exists whether or not anyone is thinking about it. The Keeler Gap. 42 kilometers of swept, clear lane. The A-ring curving away on either side into the dark. The ice particles drifting in their separate orbits, each one free, each one answering to gravity on its own terms, as James Clerk Maxwell predicted and James Edward Keeler confirmed, and as Daphnis has been demonstrating quietly and continuously for a very long time. The elder sibling keeps its wider lane, the younger, smaller one keeps its narrower channel. And the narrower channel, it turns out, is the one where something stranger and more particular happens, where the waves do not just ripple outward in the plane of the ring, but climb upward, out of the plane, into the space above and below, into the third dimension that the ring's own long history of gentle collisions has been working to suppress. How that suppression gets undone, what it is about Daphnis's orbit, its slight tilt, its gentle eccentricity, that gives it the means to do what Pan, in its wider lane, does not do with quite the same drama. That is what we are building toward, step by quiet step, in the hours that remain. And we will get there. There is no hurry, and the path is worth taking at this pace, with the dark settled in around you, and nothing required of you tonight except this, to breathe, and let the story come, and rest inside it as it moves. The gap is open. The moon is circling. The ice is waiting at the edges, as it always waits, for the moment the little shepherd comes round again and asks its quiet question. And the ice, as it always does, begins to rise. And the rising is the thing that requires some patience to understand, because it is not obvious, not at first. The obvious version of what Daphnis does goes something like this. A small moon moves through a gap. Its gravity pulls on the nearby ice, and the ice moves a little. Simple, tidal nudging. The kind of thing that happens wherever a body with mass moves near other bodies with mass, all the way down to the way the moon lifts the ocean beneath it on a slow, long breath twice each day. You might expect the story of Daphnis to be a version of that story, scaled down. A small moon in a narrow gap, making modest horizontal ripples in the ice along its edges, the way a slow-moving boat makes modest horizontal ripples on still water as it passes. You might expect the ripples to stay flat, to stay in the plane of the ring, where everything else in the ring stays, where the quiet pressure of 10,000 years of collisions has flattened and sorted and settled every last grain of ice into that almost impossibly thin sheet. But the ripples do not stay flat. And the reason they do not stay flat has everything to do with two quiet facts about Daphnis's orbit, two small deviations from the perfectly circular, perfectly level path that the simplest version of the story would assign it. The orbit is slightly inclined, and the orbit is slightly eccentric. Neither deviation is dramatic, neither one announces itself, but each of them, working in its own way on the ice at the gap's edges, is enough to take what would otherwise be a flat horizontal ripple and give it a third dimension, enough to make it rise. Begin with the inclination, because that is the one that lifts things. To say that Daphnis's orbit is inclined is to say that the path the moon follows is not perfectly aligned with the flat plane of the ring. It is tilted, just a little, like a coin that has been set spinning on a table and has not yet settled completely level, leaning a fraction of a degree away from horizontal. The angle is small. You would not notice it if you watched Daphnis from a great distance. The moon would appear to trace a gentle ellipse around Saturn, as every moon does, and the tilt would be nearly invisible against the scale of the system it inhabits. But the ring particles at the edges of the Keeler Gap notice. They notice because when Daphnis passes closest to them, and it passes close, skimming within roughly 20 kilometers of each gap edge, sometimes closer on the inner side, sometimes closer on the outer, depending on where it is in its slightly oval path, the gravitational pull it exerts does not arrive from perfectly within the ring plane. It arrives from slightly above the plane, or slightly below, depending on where in its tilted orbit the moon currently sits. And a pull that comes from slightly above the ring plane does not only push a particle sideways, it also pulls it up. A pull from slightly below does not only push it sideways, it also pulls it down. The horizontal tug and the vertical tug arrive together, and the vertical component, even though it is smaller, is enough. It is enough to give the disturbed particles a velocity that is not purely horizontal. It is enough to send them climbing out of the ring plane on trajectories that are only a little off from flat, but a little off from flat, held and amplified across the full wave cycle, is all it takes. Think of it this way. Picture a flat piece of cloth stretched tight and perfectly level. You slide a small rounded object along the surface at a consistent height, and because it is at the same height as the cloth, the disturbance it creates stays in the plane of the cloth. The fabric dimples and ripples outward to either side, but not upward, because there is no vertical component to the push. Now tilt the object's path by the smallest angle. Let it travel along a path that is just slightly raised above the cloth on one end of its motion and just slightly below the cloth's level on the other. Suddenly, the cloth does not only ripple sideways, it billows. And in the ring, the billowing is what we are talking about when we talk about the vertical waves. The billowing that a slight orbital tilt, acting on particles that are already sensitive to even tiny disturbances, is enough to produce. Those particles, disturbed from the flat path they were keeping, do not simply pop upward and then fall straight back down. They continue in their own orbits, carrying the upward velocity they received from the passing moon, and as they go, they trace a path that rises above the ring plane and then curves back, and then, eventually, over the course of their continuing circuit around Saturn, returns them toward the plane again. The vertical perturbation becomes a vertical wave, a standing ripple of ice above and below the ring's ordinary surface, spreading out from the gap edge in a pattern that has its own wavelength, its own height, its own character. A wave that, in the case of Daphnis's perturbation, can reach up to roughly 1 kilometer and perhaps a little more, above the surface of the ring. 1 kilometer. In ordinary life, that is not a very large number. 1 kilometer is the distance you might walk in 10 or 12 minutes on a clear afternoon. It is the distance from the bottom of a modest valley to the ridge above it. It is not a height that would register on its own as remarkable, but here it must be held against something else, and what it must be held against changes everything about what the number means. The ring that these waves are rising out of, the ring that is their floor, their foundation, the ordinary surface from which they climb, is in most places, across most of its vast expanse, on the order of 10 meters thick. Not 10 kilometers, Not 10 miles, 10 meters, approximately the height of a 3-story building. The depth of a modest swimming pool if you laid it on its side. The distance from the ground to the roof of a slightly taller than average house. And so, the wave rises 1 kilometer above a surface that is 10 meters deep. That proportion, 1 kilometer of wave standing on 10 meters of sheet, is the proportion you would get if you took a piece of paper, laid it flat, and placed on it a vertical structure roughly 300 times the paper's thickness. If you have ever held a sheet of paper up to the light and tried to imagine a wave rising from it that was 300 times as tall as the paper itself was thick, you have some sense of what the ring looks like in the vicinity of the Keeler Gap. The ring is the paper. The wave is 300 sheets of paper stacked in the air above it, shivering in place, perfectly poised in the quiet of Saturn's gravitational field, rising and spreading along the gap edge as Daphnis continues its orbit, slow and unhurried, 14 hours for each full circle. Each pass leaving a fresh ripple behind it, and the old ripple still subsiding ahead of it. And here is where the second quiet deviation, the eccentricity, enters, because the orbit of Daphnis is not perfectly circular, it is slightly oval. It breathes. Over the course of each 14-hour circuit, the moon moves a little closer to Saturn at one end of its path and a little farther away at the other, and because its distance from the gap edges changes as it goes, the strength of its gravitational tug on those edges also changes. When Daphnis is at its closest approach to a given stretch of gap edge, it pulls more strongly. The wave it raises there is a little taller, a little more emphatic. When Daphnis is at its farthest, the pull softens. The wave it raises is a little lower, a little more subdued. The effect is to make the whole wave pattern breathe, in a manner of speaking. Not all at once, not with a single synchronized swell and fall, but in a rolling, continuous variation that means no two stretches of the gap edge are experiencing quite the same thing at quite the same time. One section might be in the crest of a taller perturbation, while a section slightly ahead of it in the moon's passage is already fading from an earlier, gentler one. The gap breathes unevenly, rippling at different heights along its length. The waves swelling and easing as the slightly oval orbit carries Daphnis through its steady, repeating pattern. Each pass is similar to the last, but not identical. Each wave is the product of the same forces, but shaped by the particular moment in the orbital breathing cycle at which it was raised. There is also the matter of the two gap edges and the way they ripple not as mirror images of each other, but as something offset and slightly out of step. To understand why requires sitting with the basic fact of how things move in orbit around a large body like Saturn. The rule, which holds everywhere in the solar system, and which is just a consequence of the same gravity that keeps everything in place, is that inner orbits are faster than outer ones. A particle in a ring closer to Saturn moves faster along its path than a particle in a ring farther away. Not by an enormous amount, not dramatically, but measurably and reliably. And this rule does not stop applying at the edges of the Keeler Gap. It continues right through. The particles along the inner edge of the Keeler Gap, the edge slightly closer to Saturn, move a little faster along their orbits than Daphnis does along its own. They are slightly interior to the Moon, and so they are slightly faster. The particles along the outer edge of the gap, the edge slightly farther from Saturn, move a little slower than Daphnis does. They are slightly exterior, and so they are slightly slower. This difference in speed, small as it is, matters enormously for how the wave pattern forms on each side. When Daphnis passes a stretch of the inner edge, the particles there are already moving faster than the Moon. After the Moon has gone past, those particles are moving on ahead of it, leaving the point of closest approach behind them as they continue around their faster inner orbit. The disturbance the Moon has produced, the sideways and upward tug of its gravity, reaches those particles, and then the particles carry it forward, ahead of where the Moon was, carrying the wave upring from the encounter point. And because the inner edge particles are faster than the Moon, the wave pattern along the inner edge leads the Moon slightly. It forms ahead of the encounter, displaced in the direction the particles are travelling. The outer edge is the reverse. The particles there are slower than the Moon. When Daphnis passes, they are falling behind. The Moon overtakes them, moves ahead, and the disturbance the Moon has produced reaches particles that are now trailing behind where the encounter happened. The wave along the outer edge lags the Moon slightly. It forms behind the encounter, displaced in the direction the Moon has already come from. The result is that the inner edge waves and the outer edge waves, even though they are produced by the same Moon, making the same pass at the same moment, end up pointing in opposite directions along the gap. One set of crests runs ahead of Daphnis, the other set runs behind. They are not mirror images. They are offset. If you were looking down at the Keeler Gap from above, if you could see both edges at once and trace the wave patterns along them, you would see something like two coiling, opposite tendrils, the inner one curling one way and the outer one curling the other, and between them the dark lane of the gap itself, kept clear and orderly by the continuous, quiet, slightly asymmetric work of the Moon. This is the structure. This is what the gap looks like from the outside, and what Cassini eventually confirmed with images of a resolution and clarity that had not been possible in the earlier years of the mission. The two edges, each with their own wave character, each responding to the same gravitational influence but from different sides of the speed threshold that the Moon's own orbit defines. And between the two rippling edges, Daphnis, small, dark, rounded, moving at the pace it has always moved, 14 hours for each circle, unhurried and patient as anything in the ring system. And Daphnis itself, as it turns out, carries on its surface a record of a different interaction with the ring material around it. Not the waves it makes, but what it has accumulated. Over the course of a very long time, longer than any human institution, longer than any recorded history, longer even than the civilizations that named the stars and charted the planets. Daphnis has been sweeping through the Keeler Gap, and as it has swept through, some of the ring material it disturbs has not simply rippled away from it. Some of it has eventually settled onto the Moon itself, drawn inward by the Moon's own small gravity, landing not randomly across the surface, but preferentially around the equator. The region where the geometry of the Moon's motion and the ring plane means the infalling material is most likely to arrive. The result is a feature visible in the Cassini images, a narrow ridge, a raised rim running around the equator of Daphnis like a belt or a seam. Not a dramatic mountain range, not a high cliff. A relatively subtle elevation, a collected accumulation of ring material that has been deposited there over time, thickening the equatorial region of the Moon into a gently convex outline. The ridge gives Daphnis a shape that has been compared, in the observations of the Cassini imaging team, to something like a ravioli, a rounded body with a slight equatorial thickening, a seam running around its middle. Or, in other framings, something resembling a flying saucer, a central body with a subtle peripheral rim. Daphnis is not the only ring moon to show this feature. Pan, in the Keeler Gap, has a more pronounced version of the same thing, a wider, more dramatically raised equatorial ridge that makes Pan's ravioli silhouette quite unmistakable in images taken close enough to resolve it clearly. Atlas, another small Saturn moon that lives just outside the A-ring's outer edge, shows a similar accumulation. The pattern seems to be a general consequence of a moon spending a very long time in intimate contact with a ring system's material, collecting it, being shaped by it, wearing its history in the form of a gently thickened equator. In Daphnis's case, the ridge is a kind of archive, a physical record of the slow, continuous interaction between a small icy body and the particles it has been orbiting among. Every grain of ice that eventually settled onto that equatorial belt was once a free drifting ring particle, obeying the same differential orbit rules that govern every other particle, tracing its own path around Saturn at its own speed. Until it came close enough to Daphnis that the tiny moon's gravity was enough to claim it. Slowly, grain by grain, over time that is very difficult to comprehend without simply letting it wash over you as a feeling rather than a count, the ridge has grown. Not all at once, not in any event you could point to or date. Simply continuously, quietly. The way all the most significant accumulations in nature tend to happen, so gradually that the change at any moment is imperceptible, and the change across the whole span is enormous. The moon itself is an accumulation of a similar kind. What Daphnis is, in its interior, what it is made of and how it is put together, is not directly measurable with the instruments that Cassini carried. The spacecraft could photograph the moon from 28,000 kilometers and resolve its shape, its ridge, its general surface texture. It could watch the waves Daphnis made and deduce from them the strength of the moon's gravitational influence. But it could not look inside. It could not weigh Daphnis directly, the way you might put an object on a scale. What scientists can do is work backward from the perturbations the moon causes in the ring, and from estimates of the moon's volume, which is roughly the volume of a rounded body about 8 kilometers across, and from those quantities arrive at an estimate of the mass. That estimate places Daphnis somewhere around 10 to the 13th or 10 to the 14th kilograms. Those numbers, in the abstract, do not carry much feeling. 10 to the 13th is a 10 followed by 13 zeros. 10 to the 14th is a 10 followed by 14 zeros. Together they bracket an order of magnitude of uncertainty that is honest about what we know and what we are inferring. But even within that range, the implied density, the mass divided by the volume, suggests a body that is not dense in the way that rock is dense, not compact and solid in the way that a small asteroid made of iron or silicate might be. The density implied is low, loose, suggestive of a body that is porous, full of internal space, held together more by the gentle self-gravity of a loosely bound collection of material than by any internal cohesion that would make it rigid. Daphnis is, in all likelihood, a rubble pile, or an ice pile, a collection of icy material, ring-sourced or ring-adjacent, gathered together under its own small gravity into an approximate sphere, or rather an approximate flattened sphere. Given that equatorial ridge, without the internal pressure or the thermal history that would compact it into something solid. It is porous the way a very loosely packed snowball might be porous if you made one out of the lightest possible snow and then let it sit undisturbed for a very long time. It probably has spaces inside it, gaps and cavities in the interior that are not filled by ice or by anything else. A body held together gently, loosely, in the way that the ring particles around it are also held in their collective structures, not by strength but by gravity, and by the particular conditions of a cold, quiet, slow system in which there is no violent process reshaping things from moment to moment. This porosity, if the estimates are right, is actually consistent with what we know about how moons in this region of Saturn's ring system are thought to form. The leading idea is that the ring moons at Saturn's inner edges and gap positions did not arrive fully formed from somewhere else and simply fall into their current orbits. Instead, they grew in place, accreted from ring material that slowly clumped together over time at dynamically favorable locations, collecting additional material as it went, gradually accumulating mass until it had enough gravity to keep pulling more material in rather than losing it back to the ring. If that is how Daphnis formed, then it is not merely a body that shapes the ring around it. It is a body that was made by the ring, built from the same raw material that still surrounds it on every side, still drifting past in separate orbits, still answering to Saturn's gravity, one particle at a time. A moon made of ring material, shaping the ring material, collecting more ring material along its equator, and slowly, over time, creating the conditions in which the ring material at the gap's edges is lifted into kilometer-tall waves that spread outward across the ice in slow, quiet, repeating patterns that rise and then fall and then rise again. The whole system is circular in this sense, not just in the orbital sense, though it is that too, but in the causal sense. The sense in which the maker and the made are not entirely separate things. Daphnis came from the ring. The ring answers to Daphnis. The ridge on Daphnis is ring material returned. The waves in the ring are Daphnis's signature written in ice at full scale once every 14 hours, endlessly, and because the orbit breathes, because the eccentricity varies the pull over each circuit. The writing is not perfectly uniform. The waves that trail from one edge of the gap are not exactly the same height or the same spacing as the waves that trail from the other pass, the one before or the one after. The pattern repeats, but it does not repeat identically. There is variation inside the repetition, a natural variation, built into the orbital mechanics. That means the gap edges are always slightly different from how they were the pass before, and always slightly different again from how they will be the pass after. The same basic structure, the same basic mechanism, but never quite the same expression of it twice. This is a property the ring shares with a great many natural oscillating systems. The way a tide is never quite the same as the last tide, even though the forces generating it are the same forces they have always been. The way a wave breaking on a shore is never quite the same as the wave that broke before it or the wave that will break after. The repetition and the variation coexist, and it is the coexistence of the two that gives the pattern its quality of being alive in some way, of having something more than pure mechanical regularity. Not alive in any biological sense, simply dynamic in the way that real physical systems tend to be dynamic, rich enough in their internal structure that pure repetition is never quite achieved, and rich enough in their underlying order that the variation never tips into chaos. The Keeler Gap, with Daphnis circling inside it, is such a system. Every 14 hours the moon comes round. Every 14 hours the edges respond. Every 14 hours the waves rise. And every 14 hours the particular expression of the rising is slightly different from the 14 hours before. Because the orbit breathes, and the position of each encounter along the slightly oval path is never quite the same twice. The same story, told again, in slightly different words, by a narrator who has been telling it for longer than there have been words. You do not need to track all of this to rest inside it. You do not need to hold the differential orbit mechanics and the inclined plane geometry and the eccentric orbit breathing pattern all in mind at once. These details are here for the ones who want them, and they will still be here in the morning. What the system offers for now, for this hour, is simpler than all of that. It offers a rhythm. The rhythm of a small, porous, ridge-bearing moon making its circuit. The rhythm of ice responding to a gentle gravitational touch. The rhythm of waves that rise and spread and ease and come again, in a loop that has no urgency and no destination, that simply continues because the physics of Saturn's gravitational field and the physics of a slightly tilted, slightly oval orbital path make it continue, automatically, without intention, without effort, without end. The waves are rising now. They have been rising through all of this, through everything we have covered and everything we will still cover, through the long middle hours of the night, and through whatever sleep finds you if it comes. Over the Keeler Gap, which is 42 kilometers of darkness between two bright walls of ice, the walls themselves are not perfectly flat. They are gently undulating, catching what light reaches them from a sun nearly 1.5 billion kilometers away. The crests of the waves rise up from those walls, not sharply, not dramatically, but in the slow and gentle incline that a kilometer's height, spread over a long horizontal distance, actually amounts to. The incline of a very long, very gradual hill. Nothing sudden, nothing that would startle, just a continuous, slow rising and then a slow falling, like breath. There is a moment coming, a particular moment in the history of Cassini's long watch over Saturn, when those waves, which had existed for as long as Daphnis had orbited, suddenly became visible for the first time in a new way, when what had been inferred and modelled and understood in the abstract was suddenly caught in actual light, casting actual shadows across the actual ice, in a configuration that had never quite existed before in all the years of the mission. A moment when the ring turned its edge toward the sun, and everything hidden in that third dimension stepped briefly into the light. That moment is still ahead of us in the part of this story that belongs to the proof. But the mechanism that made the moment possible, the inclined orbit, the eccentric orbit, the differently paced edges, the rising waves, the breathing gap, the porous little moon with its ridge of collected ice. All of that is now laid out. All of that is in place. And Daphnis circles on, indifferent to the naming of its parts, unbothered by the long effort of understanding that has been directed at it from a small blue planet much closer to the sun. It does not know it was discovered in May of 2005. It does not know its designation is Saturn XXXV, or that for a brief period it was known only as S2005-S1. A provisional label assigned while the paperwork of formal naming moved through the slower channels of the International Astronomical Union. It does not know it was named after a shepherd, though the name fits it as well as any name has fit any body in the solar system, for reasons that will come in their own time. It only orbits. It only tugs. It only makes its waves and collects its ridge and breathes its slightly oval breath around the equator of Saturn once every 14 hours in the dark. The gap waits, as the gap always waits. The ice at both edges hangs in its slightly disturbed configuration, the inner edge waves displaced ahead of the moon, and the outer edge waves displaced behind. The crests of the vertical perturbations rising away from the plane of the ring in the direction of the sun and in the direction of the outer darkness, symmetrically, into the space that the ring's thinness would otherwise leave entirely empty. And somewhere in that space above the waves, in the quiet region, a kilometer or so above what a particle in an unperturbed ring would call home, the ice crystals that were nudged there by a gravitational whisper are drifting along their temporary off-plane trajectories, each one on its own small arc, each one on its way eventually back toward the ring plane that its kind has been trying to flatten itself into for a very long time. They will come back down, eventually. They always do. The orbit curves them back, and then Daphnis will come round again, and they will rise again, and the gap will remain open, and the waves will remain, cycling through their rise and their fall as faithfully as anything in the solar system cycles through anything. The mechanism does not tire. The mechanism does not wonder when it will end. It simply continues, because continuing is what the mechanism does. Rest in that for a moment if you can. The waves are still rising. And there is a moment in the history of this particular story, a moment when the waves became visible not as a mathematical prediction, not as a theoretical disturbance worked out on paper from the known eccentricity of a small moon's orbit, but as a physical, measurable, shadow-casting fact that anyone with eyes could recognize for what it was. That moment arrived not because a spacecraft moved closer, not because an instrument became more sensitive, but because the sun moved, because the geometry of the solar system turned as it turns on a scale of years, and the angle between the sunlight and the plane of Saturn's rings passed through a threshold that happens only once every 15 years or so. The threshold is called equinox. On Earth, equinox is a familiar rhythm. Twice a year, the sun crosses the celestial equator, and for a day or two the length of daylight and darkness balance against each other almost evenly across the whole planet. You feel it in the quality of the morning light, in the angle of a shadow thrown by a fence post, in the way the late afternoon sun seems to travel sideways rather than straight down toward the horizon. It is a gentle thing, mostly a seasonal hinge. But Saturn's equinox is a different matter, and not only because Saturn's year lasts roughly 29.5 Earth years, so that each equinox arrives separated from the last by almost 3 decades. It is also different because of the rings. Saturn's rings extend outward from the planet in a plane, a flat, spinning disk of ice and rock that hugs the equatorial zone of the planet and does not tilt meaningfully away from it. When you look at Saturn from far away, the angle at which you see the rings depends on where both you and Saturn happen to be in their respective orbits. Sometimes the rings appear wide open, tilted toward you at a full angle, showing their breadth and brightness in their entirety. Sometimes, as Saturn's equinox approaches, the rings edge toward you, tilting more and more toward the line of sight, until at the equinox itself they present their thinnest possible face, a line, almost, a razor of reflected light, barely visible even through a good telescope. And the sun, at that same moment, strikes the rings not from above or below, but nearly horizontally, almost parallel to the ring plane itself, laying its light across the surface of the ice at an angle so shallow that any vertical structure rising from that plane throws a shadow not a little way, but a very long way, stretched out across the ice in the direction of the light. This is what happened in August of 2009. Saturn reached its equinox. The sun's angle to the ring plane narrowed toward edge-on, and the Cassini spacecraft, which had been orbiting Saturn since July of 2004, was there to watch it happen. And what it watched was extraordinary. In the particular quiet way that genuine discovery tends to be extraordinary, not dramatic, not sudden, but clarifying, the way a room looks when someone finally opens the curtains, and the things you knew were in the room are suddenly exactly where you expected them to be, and also somehow different from how you had imagined them. The waves that Daphnis makes, the vertical structures that rise up from the plane of the Keeler Gap's edges when the moon's slightly tilted gravitational influence lifts ice particles up and out of the ring plane, those waves had been inferred. They had been modelled. The orbital mechanics of a slightly inclined, slightly eccentric moon moving through a narrow gap predict them straightforwardly enough. But inference and model are different from measurement, and measurement requires that the thing you want to measure cast some kind of signal you can read. In the ordinary geometry of Saturn observation, with sunlight coming at the rings from well above or well below the plane, a vertical structure 1 kilometer tall on a ring only 10 meters thick simply does not have enough face to catch the light in a way that separates it meaningfully from its surroundings. The ring glows. The waves, which are also made of the same glowing ice, glow too. The contrast is not there. But when the light comes in sideways, nearly parallel to the plane, the vertical wave becomes a sundial. It stands up from the surface and casts its shadow across the flat ice behind it, and the shadow's length is a direct record of the wave's height, readable with simple geometry. If you know how low the sun is, you can measure the shadow and calculate what made it. The 2009 Equinox gave Cassini that geometry, and the shadows Cassini saw along the edges of the Keeler Gap were long. Not long in a modest, barely detectable way. Long in a way that required waves reaching roughly a kilometer above the ring plane. A kilometer above a ring that is in the same place, something on the order of 10 meters from top to bottom in its unperturbed state. Think about that proportion again. Think about a sheet of paper lying flat on a table. Not a thick book, not a stack of pages, but a single sheet, roughly 1/10 of a millimeter thick. Now think about a wave rising off the surface of that sheet to a height of 10 centimeters. A wave that is 1,000 times taller than the medium it rises from. The physics that produces this in Saturn's rings is the same physics, scaled up by many millions. Daphnis's tug on the edge particles, the orbital geometry that converts that tug into a vertical excursion, the extreme thinness of the ring itself that makes the resulting wave so disproportionate. But the proportion is real. The 10-meter ring. The kilometer wave. The sun coming in flat across the surface in August of 2009, and Cassini watching the shadows that those waves threw across the ice. The measurement was not an approximation. The shadows were real, and their lengths were real, and the heights calculated from them, up to roughly 1 to 1.5 kilometers, at the crests of the waves closest to Daphnis's path through the gap, were as real as any measurement the mission had made. What had been a theoretical prediction became a number with units. What had been a model became a shadow. And the shadow made it, in a way that pure calculation cannot quite make things true. There is something to be said for the timing of that revelation. Cassini arrived at Saturn in 2004. Daphnis was discovered in the Keeler Gap in 2005. The Equinox came in 2009. 5 years of orbiting. 5 years of imaging the rings at angles that showed their face but not their vertical structure, And then the geometry rotated into the one configuration that could reveal the height of the waves. And the waves were there, exactly as the physics said they should be. Not smaller than expected, not larger. Roughly the right size for an 8-kilometer moon with a slightly tilted, slightly oval orbit, nudging the edges of a 42-kilometer gap of pure water ice. The solar system had, in its slow and impersonal way, provided the proof. And then the geometry continued rotating, as it always does, and the equinox passed, and the sun's angle to the rings shifted away from edge on, and the shadows grew shorter and then disappeared. And the ring plane returned to its more familiar presentation, face on, bright, the waves invisible again, except to the mathematics that knew where to look. Saturn did not announce the equinox or mourn its passing. The rings continued their slow, precise revolution around the planet. Daphnis continued its much faster loop through the Keeler Gap. The waves continued rising and falling. The shadow-making was over for another approximately 15 years. But the measurement had been made. The kilometer was on record. The other proof, the second one, the one that catches you in a different way, not in the way that a measurement catches you, but in the way that a single image sometimes catches you, came much later. It came in January of 2017, near the end of the mission, during a phase of the Cassini flight plan called the ring-grazing orbits. These were orbits designed to bring the spacecraft closer to the outer edges of Saturn's ring system than it had ever come before, skimming just beyond the outer edge of the A-ring, dipping in and out of the ring plane itself, trading the safety of distance for the reward of resolution. And on January 16th of that year, during one of those ring-grazing passes, Cassini turned its cameras toward the Keeler Gap from a distance of approximately 28,000 kilometers, roughly 17,000 miles, and took the highest resolution images of Daphnis it had ever taken or would ever take. The moon is there in the photograph, small and pale and shaped in the rough way of something that has accumulated its material rather than having been formed into a smooth sphere, irregular, slightly flattened, with the suggestion of that equatorial ridge, the swept-up skirt of ring material that has settled onto it over a very long time. Around it, the Keeler Gap opens on both sides, a darkness, a lane of absence between the bright walls of the A-ring's ice. And along those walls you can see the waves. They are not dramatic in the image, they do not announce themselves. They are subtle undulations along the edges of the gap, a gentle wrinkling of the bright ice edge that you might initially mistake for optical noise or for the uneven brightness of the ring material itself. But they are there, and once you see them, you do not unsee them. And then, in the image, there is something else. Extending from the inner edge of the gap, the edge closest to Saturn, the edge whose particles orbit a little faster than Daphnis, and so arrive at the gap boundary slightly ahead of the moon, and then trail away behind it, there is a thread, a faint line of material, barely distinguishable from the surrounding brightness, reaching across the darkness of the gap toward the moon. Not a wave, not a ripple, something more specific than that, a tendril, a strand of ring ice that has been pulled by the gravity of the passing moon away from the edge and out into the gap in the direction of Daphnis itself, a thread of stolen light, a piece of the ring that was momentarily, gently, captured by the gravity of the shepherd. It is thin, it is faint. In a less detailed image, it would not be visible at all, or would look like noise. but from 28,000 kilometers, with Cassini's camera at its full resolution and the ring-grazing geometry bringing the spacecraft closer than it had ever been to this part of the ring system, it is there. A single strand. The wave-making made visible not as a shadow in equinox light, but as the thing itself, a piece of ice leaving one place and being drawn toward another, the gravitational relationship between moon and ring rendered in a single delicate filament extending across 42 kilometers of cold darkness. The tendril was a gift, in the sense that good images sometimes are, not planned for. Not specifically predicted in that form, but legible once seen, a direct picture of the mechanism that the mission had spent years measuring indirectly. Here is the gravity, here is the ice, here is the distance between them, and here is the thread that the gravity drew across that distance, as gently as anything in the solar system draws anything across anything. It does not rush. It does not pull hard. It simply makes itself known, the way a moon 8 kilometers across makes itself known to a ring of ice 40,000 kilometers around, quietly, patiently, by being there and continuing to be there, orbit after orbit, for as long as the solar system runs. The name Daphnis comes from the Greeks. It belongs to a figure from pastoral mythology, a shepherd, the son of the god Hermes, who was said to have been left as an infant in a grove of laurel trees and raised among herdsmen. Daphnis became in time a figure associated with the care of flocks, with the slow rhythms of grazing and guiding and tending, with the knowledge of where the animals need to go, and the gentle, persistent work of keeping them there. It is from this mythological tradition that the word pastoral itself draws some of its meaning, the idea of a guiding presence that does not force but simply accompanies, that keeps the flock moving in the right direction, not through violence, but through knowledge and patience and the steady application of attention. The International Astronomical Union gives names to the moons of Saturn from the traditions surrounding that planet's mythological associations, and when the Cassini team discovered the small moon in the Keeler Gap in 2005, the name Daphnis was chosen for reasons that any reader of the mythology would recognize immediately. The moon herds the gap. It does not force the ice. It does not blast a lane through the ring the way a much larger body would, in a single catastrophic pass. It glides through, once every 14 hours, and its gravity speaks to the particles on each side, and the particles adjust, and the ones that had drifted too far into the lane are nudged back out, and the gap remains open. The shepherd passes. The flock holds its shape. The lane stays clear. The fit between the name and the role is rare, one of those occasional moments in the naming of things when the ancient story and the physical reality seem to have been made for each other, as though whoever wrote the myth had somehow seen the Keeler Gap, had somehow watched the tiny moon moving through it, had understood the quiet mechanism and encoded it in a pastoral figure left as a child in a grove of laurel trees to grow up tending flocks. They did not, of course. The myth is very old, and the Keeler Gap was not a known thing when the myth was being told. But the convergence stands, and it is the kind of convergence that makes the naming of moons feel, now and then, like more than administrative record-keeping. The Keeler Gap itself carries a different name from a different tradition, the name of James Edward Keeler, an American astronomer who in 1895 turned a spectroscope on Saturn's rings and measured something that settled a question that had been open for decades. The question was this: are Saturn's rings solid, or are they made of countless individual pieces? It sounds, in retrospect, like a question with an obvious answer, and perhaps by 1895 the theoretical case was already strongly in favour of the latter. James Clerk Maxwell had shown mathematically, decades earlier, that a solid ring would be unstable and would break apart, that only a ring made of countless independent particles, each orbiting on its own, could persist in the way Saturn's rings persisted. But mathematical argument and physical measurement are different kinds of knowing, and Keeler's spectroscopy was physical measurement. What Keeler found when he measured the Doppler shift of light reflected from different parts of the rings was this: the inner parts of the rings moved faster than the outer parts. Not by a little, by exactly the amount that individual particles in free orbit around Saturn should move faster on the inside than on the outside. The same relationship that governs the motions of the planets themselves, where the inner planets orbit the Sun more quickly than the outer ones. If the rings were a solid disk, they would rotate like a spinning top, with the outer edge moving faster than the inner edge. Instead, they moved like a system of free-orbiting bodies, each at its own speed, each answering only to Saturn's gravity and to nothing else. The rings were particles. Maxwell had been right. And the Keeler Gap, the narrow lane that the shepherd moon Daphnis would be found keeping open 110 years later, was named in that astronomer's honour, a gap named for the man who proved that the thing it was cut through was not solid at all, but ice. Countless pieces of ice, each on its own quiet path. Cassini was launched on October 15th of 1997. It was not the first spacecraft to visit Saturn. Pioneer 11 had passed through in 1979. And Voyager 1 and Voyager 2 had made their flybys in 1980 and 1981, respectively, but it was the first to stay. It entered Saturn's orbit on July 1st of 2004, firing its main engine to slow itself enough to be captured by the planet's gravity rather than flying past, and it spent the next 13 years circling Saturn in an ever-varying series of orbits, changing its flight path again and again by flying close to Saturn's moons and letting their gravity redirect it. Each new orbit opening a different angle, a different distance, a different view of the rings or the atmosphere or the moons themselves. The Daphnis discovery came a year into the orbital tour in May of 2005 from images of the Keeler Gap taken by the Cassini imaging science team. The Equinox campaign was a planned scientific activity, scheduled years in advance and executed in the summer of 2009 when the geometry arrived. The ring-grazing orbits and the close-up image of January 16, 2017 came near the end of the mission's life, in the period when the spacecraft had very little maneuvering propellant remaining, and the science team and mission planners had decided to use what was left for a final series of close passes. Daring, high resolution, close-in observations that could not have been risked when the mission was young and the spacecraft's longevity had not yet been established. And then, on September 15th of 2017, Cassini plunged into Saturn. This was not an accident and not a mechanical failure. It was a deliberate choice, made years in advance for reasons that had to do with the integrity of the solar system, specifically with the integrity of Titan and Enceladus, Saturn's two moons where Cassini had found evidence for liquid water and conditions that might, in principle, support life. The spacecraft was running out of propellant, and without propellant to steer it, it would eventually drift out of control and might, at some point in the future, collide with one of those moons, contaminating them with the Earth microbes that had hitched a ride on the hardware despite all the cleaning and sterilization. Better to end the mission on a known trajectory into Saturn's atmosphere, where the spacecraft would burn and break apart and become part of the planet itself, than to let it wander and perhaps touch a world that science had not yet finished examining for signs of its own life. So Cassini went in. The instruments kept transmitting until the very last moment, the last fraction of a second before the heat and pressure overwhelmed them, sending back atmospheric data about Saturn's upper cloud layers that no mission had ever been positioned to collect. And then the transmission stopped, and the mission was over, and the spacecraft that had found Daphnis and watched the Equinox shadows and taken the close-up image with its single tendril of stolen ice was no longer a spacecraft, but a scattering of atoms dissolving into a planet's worth of hydrogen and helium 13 years after it had arrived at that planet and more than 6.5 billion kilometers from the world it had been built on. The rings did not notice. Daphnis did not notice. The Keeler Gap remained open, as it always remains open. The waves along the gap edges continued their rise and fall, as they had been rising and falling for a very long time before Cassini arrived, and for a very long time after. The tendril of ice that had been visible in the January 16th image had long since been swept back into the ring, or had settled onto the moon's equatorial ridge, or had dispersed into the broader material of the gap in some way that the spacecraft was no longer there to record. But the mechanism that had produced the tendril was unchanged. The mechanism is always unchanged. Daphnis orbits. The gap breathes. The waves rise. There is a reason, beyond the beauty of the images and the elegance of the physics, why a story like this one belongs to the nighttime. Not just to astronomy in general, which has always been a nighttime pursuit, but to the particular quietness of the hour when you have put down the concerns of the day and are lying somewhere soft and dark, listening to someone speak about a place very far away. The reason has something to do with proportion, with what happens to the sense of scale when the ordinary scale of your life, your room, your neighborhood, the distance to work, the range of your daily movement across the surface of a planet is replaced, even temporarily, by the scale of a moon 8 kilometers across and a gap 42 kilometers wide, and a ring system that would fit comfortably around the orbit of the moon and still have room to spare. Something happens to the mind when scale shifts that much. The small worries that had been filling the available space, the conversations replayed, the tasks undone, the futures imagined and reimagined, find themselves suddenly in a much larger room, and in a much larger room they are smaller, not dismissed, not solved, but smaller. The way a sound seems smaller when you open a window and let in the larger sound of the night outside. The static does not stop, but the space around it grows, and the static becomes one thing among many rather than the only thing. Daphnis does not care about your static. Daphnis does not know you exist. It is 8 kilometers of porous icy rubble, loosely bound together by a gravity too faint to sense from here. Following an orbit it has followed for millions of years, nudging ice particles on the edges of a gap it has been keeping open for longer than anything you could plausibly care about has been anything at all. And yet the description of that thing, spoken slowly in a quiet room, does something to the quality of the silence afterward, makes it a little more spacious, makes the night outside, wherever you are listening from, feel a little more continuous with the night out there, where the rings catch the sun's light, and the tiny moon glides through its gap, and the waves rise from ice 10 meters thick to heights of roughly 1 kilometer, and then come back down again, as they have always come back down again, and will again. The equinox shadows are gone now. They will come back in perhaps another 15 years when Saturn's slow orbit carries it to the next crossing of the solar equatorial plane and the geometry tilts back toward edge-on. Someone will be there to see them, one way or another, a new mission perhaps, or a telescope not yet built, looking down from an orbit not yet decided on. The shadows will be long again, stretched out across the ice in the low sunlight, and the waves will be exactly the height the physics says they should be, and the measurement will confirm what the 2009 measurement confirmed, with different instruments and different hands, and the same ice and the same moon and the same 30-year cycle of a planet's turning. The rings are patient. They do not need to be measured to be real. But they do not object to being measured. Daphnis is still there. The Keeler Gap is still there, 42 kilometers wide, swept clear of stray particles by the gentle and tireless passage of the shepherd. The tendril of ice that was visible in the 2017 photograph is long gone in its specific form. Ice does not hold a shape like that for long. Not in the dynamic environment of a gap edge where orbital mechanics are constantly redistributing material, but the process that made the tendril is still running. Right now, as you are hearing this, Daphnis is somewhere in its orbit around Saturn, and the gap edges are in some phase of their wave pattern, and some particles on the inner edge are arriving at the gap boundary slightly ahead of the moon, and some particles on the outer edge are falling slightly behind it, and the differential orbits are doing what differential orbits always do. And the gravity of the 8-kilometer moon is speaking very quietly to the ice on both sides. And the ice is listening, as it has always listened, and the waves are either rising or falling, depending on where in the 14-hour cycle the moon happens to be at this particular moment. There is no instrument currently measuring this. Cassini is gone. No spacecraft is orbiting Saturn tonight. The Keeler Gap and its waves are happening in the dark, unobserved, precisely as they happen when they are observed. The mechanism does not require witnesses. The moon does not perform its orbit only when someone is looking. The waves rise and fall in the same patient silence, whether a spacecraft's camera is pointed at them or not, whether anyone on a small, warm planet 1.5 billion kilometers away is thinking about them or not. They have been doing this, by the best current estimates, for a very long time. They will continue doing it for a very long time after tonight, and somewhere in that continuation, in the steady, unspectacular, endlessly repeated cycle of nudge and ripple and rise and shadow and ease and fall, there is something that the mind can rest against. Not because it is reassuring in a simple way, not because it promises anything about your particular situation or resolves any of the specific things that might be keeping you awake. It does not do that. It is a moon, not a comfort. But because the rhythm of it is so much older than anything that concerns you, and so much larger and so completely indifferent in the pure sense of that word. Not hostile, not cold, not unkind. Simply operating at a scale and a time scale and a level of physical abstraction where your particular worries do not register as a category of thing that could possibly matter to it. That to think about it clearly. To really hold the image of the tiny moon gliding through its gap and the waves lifting off the edge of the rings in the dark, is to step briefly outside the frame of reference in which those worries are the whole of the world. The ice is still rising. Somewhere above the rings, at a kilometer or so above the plane, there are particles in slightly off-plane trajectories, following their individual arcs through the space that the ring's thinness would otherwise leave empty, on their way back down. They will come back. They always do. The orbit curves them. And Daphnis will come round again in roughly 14 hours or in 7 hours or in some fraction of the cycle that is currently underway, and it will pass through the gap again, and the particles on both edges will be nudged again, and the waves will rise again. They are still rising now. They were rising before you lay down tonight. They will be rising long after the thought of this has faded and been replaced by whatever the ordinary day next brings. The gap will be open. The shepherd will be passing. The ice will be lifted, gently, off a surface 10 meters thick, into the space above it, in crests that reach up to roughly 1 kilometer, casting no shadows at the moment. The geometry is not right for shadows tonight. But there, present, real, doing exactly what the physics says they should do, as they have done for longer than anything you are likely to worry about has existed in any form at all. The rings of Saturn are still out there. Daphnis is still passing through. Good night from up here in orbit. I'll keep watch while you drift.